Good evening, everyone. Myself Gautam Sharma. I welcome you all in on a behalf of Sapience Education. So today I'm going to discuss about the following topics. The first topic we will cover about second law of thermodynamics, Kelvin's Planck's statement, Clausius statement, reversible and irreversible process. So one by one, each and every topic will be discussed here. So let us discuss about first. That is your second law of thermodynamics. Second law of thermodynamics, it is also known as qualitative law. It is also known as qualitative law or law of degradation of energy. Before that, we need to understand what actually first law of thermodynamics has done. So as per the first law of thermodynamics, it simply states that law of conservation of energy, it does not provide any information regarding the feasibility of energy and energy conservation. What do you mean by the feasibility? Let us see here. There is a temperature of 1000 degrees Celsius, and there is another lower temperature, and this lower temperature is only 100 degrees Celsius. So a heat engine, any engine will operate between these two temperature. So what will happen? It will give a work. At the same time, there is a temperature of 101 degrees Celsius, and there is lower temperature of 199 degrees Celsius. So if heat engine operates between any engine operates between these two temperatures, so what will happen? Heat will definitely go from 101 to 99 degrees Celsius due to temperature difference. But the quality, but the amount per unit time or per work done per unit time, it is very difficult to achieve very huge power. But at this huge large difference, so it is not difficult to get a work. So we can get easily in a less time we can get the work. So but the first law of thermodynamics, as per the first law of thermodynamics, we should not he is not considering, or first law of thermodynamics is not considering the quality of the work. It is only considering the work. So no matter how much it takes the time, for example, it can take 1 year also the same amount of the work. For example, here work done is your 1000 joule. So for 1000 joule it takes a time of 1 year, but for 1000 joule it takes a time of one hour only. So definitely it is the best engine, it is the best setup. So the quality is not given by this first law of thermodynamics. So it is also, that's why second law come as per the qualitative law of degradation of energy. So first law of thermodynamics simply states the law of conservation of energy. That's all. Okay. The second law of thermodynamics gives a fundamental limitation of the efficiency of a heat engine and the coefficient of the performance of refrigerator. Second law of thermodynamics gives a fundamental limitation to the efficiency of heat engine and the coefficient of performance. It says how much efficient is the engine is that. Okay. So before that we need to understand what is a heat. Heat is considered as a low grade energy, and work is considered as a high grade energy. As a complete conversion of heat into work is not possible, while complete conversion of a work into heat is possible. So generally we have seen that whenever we have got a 100 joule of heat from this, any instrument will heat engine, suppose there is any engine will operate. So what will happen? 100% of joule can't be converted into 100 joule of work. It is not possible. But at the same time, if there is 100 joule of work has been done on the engine, so it will totally get converted into 100 joule of heat. So it is an easier, or work can directly converted into heat energy 100%, but it is not possible that heat will get converted into work directly into 100%. So that's why heat is considered as low grade of energy, but work is considered as a high grade of energy. Now we need to understand what is thermal, some of the terms. That is your thermal energy reservoir. Reservoir means what? Huge capacity. So it is a reservoir of infinite heat capacity, where either infinite amount of heat can be sent or infinite amount of heat can be absorbed. Okay. So here we will consider this as a reservoir as an infinite amount of heat absorber, or a heat we can fetch heat from the source. What is source? Continuous supply of heat energy without change in its temperature is known as source. For example, for example, there is a 200 degrees Celsius temperature, and we are continuously getting heat from this source as a rate of 20 joule per second for a very large amount of time. But at the same time, the temperature of this reservoir is not getting down. As we are fetching heat, in spite of this also the temperature is not dropping. So that type of that thing is known as a source. What is sink? A continuous absorber of heat energy without change in its temperature. For example, this is our refrigerator system, or AC. You can say AC. AC is simply absorbing heat from this room and just throw it outside the atmosphere. It does not mean that the outside atmospheric temperature will rise. No, never possible. So it is hardly you will see that due to AC there will be a rise in a temperature of the atmosphere. So that's why it is known as a sink of infinite capacity. Okay. Now let us consider what is heat engine. So heat engine consists of two thermal reservoir, and this is known as source, and this is known as sink. Okay. So from here, thermal reservoir, heat has been absorbed as a QS, and heat will be rejected as a form of QR. So QS is heat supplied or absorbed, and QR is the heat rejected. And when this heat engine operates, so due to absorption of a heat, what happens? It will do some work, and this is a work output, and it will reject the QR in the sink. Why sink? Because it is at a lower temperature. It is at lower temperature than this source. So definitely most of the heat whatever it will reject in the sink only. So as here we can see that heat supplied is here QS, work output is W, and heat rejected is QR. So as per the conservation of energy, so QS is equal to work output plus heat rejected. So we can also write here QS minus QR is equal to W. So this is the formula for getting a work done by the heat engine. Now we will come for a statement of the second law of thermodynamics. So second law of thermodynamics can be explained by the two statements. First of the statement is your Kelvin-Planck's statement. It is impossible to construct a device which operates in a cycle which produce a work continuously while interacting with the single thermal reservoir. As per this, Let us consider this is the high temperature and it is a source of heat, and there is no sink at all, so it will continuously take the heat and it will convert it into work energy. There is no rejection of heat. So as per the Kelvin Planck statement, it is impossible engine or impossible machine which will definitely operate between high temperature or which will operate with the high temperature as a single source, and it will directly give a work output. And this is known as Kelvin Planck's statement. Now let us discuss about the second statement. It is known as Clausius statement. As per the Clausius statement, it is impossible to construct a device which transfer heat from low temperature reservoir to high temperature without consuming any form of energy. As per him, as per this Clausius statement, see here, heat is being absorbed from lower temperature. It's like you can imagine there is a air conditioner room. So this is AC room, and AC is the AC is the machine which directly absorb heat from the room and reject to the atmosphere, that is atmosphere. So as per him, it is impossible if you don't supply a work in this AC. That is AC. This time, as per this engine, AC should run without any work input or without any electrical energy. Is it not possible as per the Clausius statement? So definitely we know that without any electrical energy or any type of energy, we can't operate this AC. So, but this engine is operating. So, Clausius statement says that this type of engine is a impossible engine. I hope you have understood now. Now, let us consider what is reversible as well as irreversible process. So, let us see what is statement actually says. A process is said to be reversible in which a system returns to its original state without leaving any effect on the surrounding. Just I will give you one example to demonstrate the reversible process. Let us, you have a paper, just you burn this paper. So when you burn this paper, so what will happen? It will convert into ash. So due to burning, there will be a heat ejection. There will be heat ejection. Let us suppose heat ejection is approximately is equal to 100 joule. As per reversible process, what will happen if I will put all 100 joule in this S? So it should again reconvert into the paper, but it is actually not happening. So this type of process is not reversible process. But in reversible, we have to understand that a process is said to be reversible in which system returns to its original position, original state without leaving any effect on its surrounding. For a reversible process to occur, forward and reverse path has to be the same. Yeah, path should be same. In figure, see here, in figure from 1 to 2, in figure from 1 to 2, see this is a 1 to 2 and 2 to 1, both follows the same path and hence reversible, it is known as reversible process. Let us consider when the process 1 to 2 is going on. So due to this, what happens when the process is going on from 1 to 2? Due to this, what is happening? There is a definitely heat rejection happens. Heat rejection like 100 joule. So when the process will again return from 2 to 1, so there must be a heat absorption of 100 joule. As when it goes from 1 to 2, if it rejects, so from if it has been reversed, so what will happen? It should absorb 100 joule of energy, and this type of process is known as reversible process. See, from here you can understand. See, we have uh, this is a reversible process. As we put a small amount of energy, so it will give a reversible process. As you just suck this, so it will again go to the same situation. Why we are taking a small steps or a small mass? Because it is known as quasi static process, which is practical. Quasi static process. If you take a small step, then only the process will get reversed. That's why it is also known as quasi static process. Reversible process is impossible to achieve practically. Definitely, reversible is very difficult to achieve. So that's why maximum or 100% mostly the process are irreversible process, and it is defined as the process in which the system and the surrounding do not return to their original condition once the process is initiated. For example, what happened? There is a PV diagram. Okay, pressure and volume diagram, and this is a piston cylinder case. There is a gas inside this piston cylinder. When we heat, so what will happen? So it will take the heat energy. Due to heat energy, its initial states was pressure 1, V1 volume, and T1 temperature, and final temperature. Due to heat, what will happen? Its state will change from P1 to P2, V1 to V2, and T1 to T2. And let us consider, while doing this, so it has followed this path. So this is a P1, V1, and T1, and this is a P2, V2, and T2. Okay. While following this path, so it has given output work. It has given an output work of 100 joule. So as soon as we will reverse is, so it is not possible that it will follow the same path. It may take this path, and when it take this path, while we will reverse, we have to push this by we have to do 100 joule of work. So by doing 100 joule of work, it is not possible that the heat will get reversed in the atmosphere. Heat will be out, heat will get out as 100 joule. It is not possible. So there may be a difference. Okay, so this is the case. See, this is the reversible process. So I hope you have understood reversible as well as irreversible process. So thank you for attending my class.